actually one of the reasons Jupiter has the spectacular weather, all of those beautiful bands of cloud.
Did you know the gases above Jupiter's Great Red Spot are hotter than anywhere else on the planet? Now, NASA has finally peered inside Jupiter's Great Red Spot, and we're unraveling what makes it unique.
Like, you've seen that thing on Jupiter, that storm that never quits? The big red thing, the big...
Yeah, we call it the red spot on Jupiter. We call it Jupiter's red spot.
Join us as we follow scientists armed with a sense of curiosity and cutting-edge technology to unveil the mystery of the colossal storm surrounding the gas giant. Discovering the Great Red Spot. Back in August 2011, NASA launched the Juno spacecraft on a mission to explore Jupiter, the biggest planet in our solar system.
4, 3, 2, 1, ignition and liftoff of the Atlas V with Juno on a trek to Jupiter.
It took Juno 5 years and a journey of over 1,700 million miles to reach Jupiter, finally arriving on July 4, 2016. It settled into a 53-day orbit that takes it from just above Jupiter's clouds to the outer part of its magnetic field. During its initial mission, Juno made 35 orbits around Jupiter and gathered a massive amount of scientific data, which was over 3 terabits. It also captured some stunning images of Jupiter and its moon. The best part was that Juno provided us with a look into Jupiter's Great Red Spot, the solar system's largest and most violent storm. This puzzling red orb on Jupiter is known to have existed before 1665, although the current spot was most likely discovered in about 1830. Given how varying the accounts are from people like Robert Hooks and Giovanni Cassini, it's argued that they were each talking about different spots. Either way, now it's believed that the original spot may have dissolved and regenerated over time. We've come a long way, and now we know that it's about 10,159 miles wide, which is 1.3 times the diameter of Earth. But believe it or not, it used to be even bigger. Back in the late 19th century, when scientists first took a close look at it, it was estimated to be a whopping 30,000 miles wide, over 3 times the Earth's width. In 2004, it was only half the size it was 100 years earlier. Now, scientists are worried that by 2040, it might even turn into a small circle. Now, here's the mystery. Nobody knows for sure how long this spot will stick around or why it's changing. In 2019, it started to break apart at the edges, with pieces of the storm falling off and disappearing. Some space experts think this means the Great Red Spot might vanish in the next 20 years. But there's another group who think the spot might look smaller because of all the clouds covering it, not because the actual swirling part is getting tinier. They also believe that bits breaking off could be because of interactions with other big storms, so they're not too worried about it disappearing anytime soon. Regardless, scientists are busy trying to learn everything they can thanks to Juno. Juno's findings revolutionized our understanding of Jupiter.
The launch of Juno, and with me here to talk about not only Juno but 3 new publications that just came out are Scott Bolton, the PI.
We now know that it has a complex atmosphere that goes beyond its visible clouds with a deep interior with a core made of heavy elements. Interestingly, we have a wealth of knowledge about the puzzling Great Red Spot. Let's break it down. Formation of the Big Red. Storms on our home planet happen when high-pressure forces cold air down from higher altitudes. These storms are common in high-pressure systems and usually bring cold weather. Sometimes they can even result in supercell storms, an uncommon type of thunderstorm that can create tornadoes. While scientists have a good understanding of how these storms come about on Earth, the origin and enduring nature of Jupiter's Great Red Spot remain a bit of a mystery. According to the Planetary Society, we're not entirely sure exactly how or when this massive storm on Jupiter first took shape. The astonishing longevity of the Great Red Spot is also puzzling, though scientists have put forth a few ideas. One theory suggests it might be caught between 2 jet streams flowing in opposite directions, acting like conveyor belts that keep the storm spinning. Another hypothesis is that the vertical movement of heat and cold within the storm contributes to its long life. Interestingly, a major factor in its persistence is the fact that Jupiter, being a gas planet without a solid surface, lacks the friction that would typically slow down a storm. It's no wonder that the largest storm in our solar system has truly stood the test of time. But change is brewing, one that has got scientists on edge. Wind within the storm. The winds in the outer part of Jupiter's Great Red Spot are picking up speed, kind of like a racing car. NASA's Hubble Space Telescope has been keeping an eye on Jupiter for over 10 years, making this discovery possible. They found that the wind speed at the edge of the storm, known as the high-speed ring, increased by about 8% from 2009 to 2020. In contrast, the winds closer to the center of the red spot are moving much slower, like a leisurely Sunday drive. This info comes from studying Hubble's records of Jupiter. Michael Wong from the University of California, Berkeley led the study and mentioned the finding was quite surprising. Hubble's ability to observe Jupiter over many years allowed them to notice this change, although it's a pretty small change per year. It's not entirely clear what this increase in speed means for the storm, since Hubble can't see below the top layer of clouds. But it's an interesting piece of information that could help us learn more about what powers the Great Red Spot. But Juno has come to the rescue and has now given us the chance to see how far the storm goes. Underneath the Great Red Spot. On an interesting note, scientists have long debated if the storm is just a flattened layer or does it extend downward. Scientists have finally figured out how deep Jupiter's Great Red Spot goes. Now we know it's like a rising column of stuff from deep inside Jupiter. Turns out, if you could see it from the side, it would look like a tiered wedding cake. Before the Juno spacecraft went on its mission, a team of scientists had a smart idea. They planned a special way to measure the Great Red Spot's weight during a close pass. This experiment gave them a bunch of really detailed measurements about Jupiter's gravity. This discovery is similar to discovering a hidden structure and discovering how deep it goes. Shockingly, it reaches about 500 kilometers below the planet's clouds. To put it into perspective, if a storm of this magnitude occurred on Earth, it would reach up to the International Space Station. Scientists also used special equipment on Juno to peer beneath Jupiter's clouds and discovered storms that go rather deep. They also investigated Jupiter's climate from top to bottom, discovering patterns that correspond to what we see on its surface. The truly cool thing is that they discovered Jupiter has particular wind patterns that are similar to Earth's, but there are far more of them. Because Jupiter lacks solid ground like Earth, it's unclear where these patterns end. This is the first time these patterns have been observed on a gaseous planet, and scientists believe Jupiter's magnetic field may act as a barrier for them. On the other hand, the latest data from NASA's Juno probe, released in October 2021, has unlocked interesting details about Jupiter's atmospheric phenomena. It turns out that the cyclones on Jupiter are warmer at their upper levels and have lower atmospheric densities. In contrast, they are colder at their lower levels with higher densities. Anticyclones, which rotate in the opposite direction, exhibit the opposite pattern. They are colder at the top, but warmer at the bottom. What's even more surprising is the newfound revelation that these storms are significantly taller than previously thought. Some extend a remarkable 100 kilometers below the cloud tops. Even more astonishing, the Great Red Spot and others extend over an astounding 350 kilometers downwards. This eye-popping finding suggests that these swirling vortices cover regions far below where water condenses and clouds typically form, even below the depth where sunlight directly warms the atmosphere. All of these discoveries not only help us understand Jupiter better, but also teach us things about how gassy planets work. It's kind of like going on a space adventure and finding hidden treasures in the sky. Speaking of treasures, have you ever imagined Jupiter to be a habitable planet? Water on Jupiter. Let's dive into the intriguing work of NASA scientist Gordon L. Bjorraker. He's on a mission to understand what's going on in Jupiter's atmosphere, especially when it comes to water. It seems that the Great Red holds many secrets, and Bjorraker is determined to unlock them. Using some clever technology, Gordon and his team peered through those thick clouds of the storm. It was like having to see through a dense fog, and they managed to overcome the challenge. It was only then that they were able to detect the chemical signatures of water above the deepest clouds. This discovery is unlike any other. It tells us that Jupiter has a lot more oxygen than even the Sun. Why is this important? Well, it strongly hints that there's a whole bunch of water on Jupiter, which is pretty exciting news. To gain a greater perspective, imagine if the amount of water on Earth suddenly tripled or even quadrupled, and that's how much water we're talking about on Jupiter. Jupiter's water holds a key piece to the puzzle about how this massive planet formed. Understanding its water content helps us piece together the story of our solar system. But there's a bit of a catch. To get the whole picture, we need to test this discovery in other parts of Jupiter and double-check it against data collected by NASA's Juno spacecraft. So, thanks to Bjorka's clever approach, we're getting closer to solving the long-standing mystery of water on Jupiter. Juno's final expedition. Now, in its extended mission, Juno is set to explore the entire Jupiter system, including its rings and moons, until at least September 2025, or until the spacecraft reaches the end of its operational life. Juno's delving deeper into Jupiter's secrets. It's not just about the planet itself, but also its moons like Ganymede, Europa, and Io. Juno will even fly through the charged particle clouds surrounding these moons, studying the radiation environment. There's also a new focus on the dust in Jupiter's faint rings. Plus, Juno is targeting the mysterious Great Blue Spot with a detailed magnetic survey. So it's all about broadening our understanding of the entire Jovian system. It's a truly incredible mission that's reshaping our knowledge of the giant planet and its cosmic neighborhood. Let us know how closely you're following Juno's expeditions.